So now we're moving on to 5.6. This is the inequalities in two triangles, okay? And there are several sort of theorems that we come up against, okay? The hinge theorem is one of them. As you can see from the diagram, they're looking at like a wheel jack on a car. As you can imagine, everything on that, no matter whether it's flat or whether it's slowly being raised up and lifting the car, sides will always be congruent. Okay, but the only thing that will be different, so if you've got two sides that are congruent, what's going to be the difference? It's going to be the difference in the distance between B and C. All the other measures will be identical, so you can work out which triangle is going to be bigger than the other, or what side is going to be bigger than the other. So, you know, if we're looking at this final one, this is bigger than both of these. So if we had sort of like X, Y, and Z for this last one, we can say it's bigger than the other two. Okay, so what we got here, so first and foremost, let's have a look at number one. So again, make sure you rotate it round because angle, so what we're looking at, the length in AB is the same as DG, and DE is the same as BC. So in other words, this has been rotated slightly that way. What's the difference? This one is slightly bigger than this guy. So now we know that we can say triangle ACB is greater than triangle or angle GDE. Okay. Okay, so this is explaining the hinge theory. As you can see, you've got sides that are congruent. So for instance, FE is congruent to CB, and FD is congruent to CA. But if you look at the diagram, you can see that angle F is greater than angle C, and side ED will be greater than BC. So there's a lot that you can pick it. Either you go by the angles or you can go by the side. So as you can see from real world example 2, using the hinge theory, okay, as you can see, both of these distances are 7.5, both of these distances are 5, so you've got there, but the included angle, well, this guy would be 140 because I'm taking 40 away from 180, and this guy would be 145 degrees, and you know from previous chapters that angles and sides that are opposite each other are in relation, so AC must be greater than, what's this one? I don't know what this letter is here. Well, whatever this one is anyway, let's call it DC. Okay, so we know that that is bigger than that. Okay, purely and simply because we've got this guy is 145, this is only 140. Okay, so let's have a look at number 5 using that. So 5A says which pair of segments are congruent. So looking at the dotted line, we know that AB is congruent to DE, and we also know that BC is congruent to EF. Okay, so we know that, but if you look at the diagram, you can see that the DEF triangle is bigger in angle. So if I'm looking at the angles, it says which is the measure of A, angle A greater than the measure of D. Well, by default, this guy, which is angle D, must be greater than angle A. So angle D is greater than angle A, and that, don't forget, we are now looking at angles, so this is the converse of the hinge theorem. Okay, so the hinge theorem talks about sides, the converse is talking about angles. Okay, so now we're going to put algebra in it, but let's have a look at what we've got. What we've been told that JH is congruent, so there's where your congruency is, and we're using EH as a reflection, but you've got to work out the fact that this is 65. Well, we've got to work out what sort of size this angle would be. Well, if you look at this, 11 is greater than 9. So we know that this 6x plus 15 has to be greater than 65. Okay, so now we're using it as an inequality, but basic algebra. You can work out what x is, okay, and then it's a case of then plugging it back in again if you need to. All right, so we know that it has to be 27.5, so your x has to be greater than 8 1/3 but less than 27.5. Okay, I don't like the idea of having fractions and decimals. Personally, I would have put 27.5, but never mind. Okay, but you don't know what size the angle is, you just know that that's what it's going to be. Okay, so let's have a look at what we've got this time. Alright, so what do we know? We've got two sides that are congruent, and we've used that central line, that horizontal line. But as you can see, this 5 is greater than 4, so that means this angle must be smaller than 41. So we've got 2x minus 7 must be less than 41. Okay, so using basic algebra terms, so 2x must be less than 48, so x must be less than 24. Okay, but now we're going to find the other bit. Well, the other bit is just purely and simply, obviously it's not a straight line, so we can't do that, and we haven't got the other angles. So the only thing that we can do now is that 2x minus 7, okay, must be greater than 0. Okay, because we know it's got to have some value. So now we can use basic algebra again. So 2x must be greater than 7. So x must be greater than 7 over 2. So now we're going to do 7 over 2 is less than x is less than the 24. Okay, so and basically question 7 is identical to question 6. Okay, so now we're going on to proofs. Write a 2-column proofs again. Like always, how did you find what's given? So always go what's given. And how do we know that one side is bigger than the other? That's the hinge theorem. So all you've got to do is work out which goes with which, etc., etc. All right. So it's the reflective property, addition, and then the definition of inequality. This one, maybe you could get away with not doing at all. All right. And then this time in example 5, instead of doing it in column proof, we're doing a flow proof. But basically it's the same thing. All right, this line is what you've been given. We've got the definition of a midpoint, because wherever t is, that's the midpoint all the way through the segments, especially from z and x. Okay, we've got the hinge theorem again, and then the definition of congruent angles. All right, so let's start with what we've been given in this 2-column proof. All right, so we've got triangle YZX, and then we've got YZ is congruent to XW. All right, there's our given statements. Okay, where else do we want to go from there? Well, we've got WZ is being reflective on both, so WZ is congruent to WZ, that's the reflective. All right, told you get that quite a bit. Okay, so where else can we go from there? So we've got angle 1 is also the external angle for 2 and y, and angle 2 is the external for 1 and 2. So we've got ways that we can do it. All right, so let's have a look at what we've got. So we're going to do angle 1 is the exterior angle of the triangle, what we got here. So this is going to be this YZX, all right, and that is going to be basically, no, we've lost it. No, we haven't. That's the definition of external angles, all right, and then we can just go to ZX is greater than YW, the bit that we're after. And why have we got that? Well, we've got two sides that are congruent, and we've got the inside angle, so we're back to this side angle side.